Hello everyone, this is an extra video to remind you about a topic that you have learned about before, which is solving linear equations, specifically solving linear equations using the balance method. We will first go over the method when there is only a variable on one side. Then we will have a look at what to do when the variable appears on both sides. We will have a short look at what happens with negative numbers, and finally I will summarize by listing the actual steps that you take towards using the balance method. So let's start with the variable on one side. In this case, you can actually choose whether to solve by using cards or to solve using the balance method. So suppose we are to solve by using cards and we're solving this equation 2x plus 3 equals 9. What we would do is we would cover up 2x and we would say, well, something plus 3 equals 9, so that's 6. So 2x equals 6. Then we would cover up the x and we would say 2 times something equals 6, that's 3. So x is 3. How do we do it with the balance method? Same equation. In this case, we say we want to get rid of the plus 3, so on both sides we take away 3, which gives us 2x equals 6. And then we get rid of the 2 by dividing by 2. Which ends up giving us the same answer, x equals 3. As you see, the thought process, what we think about, is different. In the one place we cover up, in the other place we give arrows. However, what we actually write down, which is the part that is in black, the actual text, is exactly the same. It has the first line, 2x plus 3 equals 9. Second line, 2x equals 6. Third line, x equals 3. So in this case, you can really decide for yourself which method to use. You will end up writing the exact same thing, and it doesn't matter. Now we get to the situation where there is a variable on both sides. So a formula like this: 5x plus 2 equals 2x plus 8. In this case, we can no longer cover up, because we would have to cover up both the 5x and the 2x. So that doesn't work. We will have to use the balance method. We will start by trying to get rid of the x on one side. We have x on two sides. We get rid of it on one side. How do we do that? We take away 2x on this side. And then, to keep it balanced, to keep it equal, we have to do the same on the other side. So we end up with 3x plus 2 equals 8. 3x because we did 5x minus 2x. And now we're back to our original situation. We only have a variable on one side. If you want to continue now by using the cover-up method, that is perfectly fine. But let's see what happens when we continue with the balance method. So now that we've got x on one side, our purpose is to get all the numbers on the other side. So we have to get rid of the 2. So we do minus 2 again on both sides, and we end up getting 3x equals 6. All right, we're almost there, but now we know 3 x's. We only want to know 1 x. So what do we do to get only 1 x? We divide our result by 3, which gives us our final answer of x equals 2. Again, you only have to write down the black part, the actual text. The arrows are optional. You can only write the arrow on one side or on both sides, as long as you remember to do the same step on both sides. We're essentially putting the equation on scales. We keep trying to balance the equation. The equal sign tells us that the left side and the right side are the same weight, so to speak. So everything that you do on one side, you must do on the other side. Then you keep that balance, it stays the same. You take the same thing away, you add the same thing. That way you will keep your balance. Okay, So using this method gets interesting once we start getting negative numbers. What can that look like? Well, for instance, like minus 2x plus 8 equals minus 4x plus 2. Here both my variables are negative. And then the question is, which one do I start with? Suppose I start with getting rid of this minus 2x. What does it mean to get rid of minus 2x? Well, to get from minus 2x to 0, to get rid of it, I would do plus 2x. You can also think of it as minus minus 2x, which is also plus 2x. What do I get then? Well, I had minus 4x plus 2x, so I still have minus 2x on that side, and only 8 on the other side. I still have to get rid of that 2 though, so let's get rid of that 2 real quick, minus 2. And I have 6 equals minus 2x. Now, it is possible to solve this, and it's perfectly fine, but a lot of people struggle here. So I'm going to say that we did the first step wrong. We want to do the first step differently. Because what we want to do is we want to remove the lowest amount of x. And minus 4x is more negative, so lower than minus 2x. So that's the one we're going to remove. So for this step, we're actually not going to do plus 2x, we're going to do plus 4x. And the nice thing then is that we go from minus 2x plus 4x, we go to plus 2x plus 8 equals 2. And this time round, we need to get rid of the 8 because we want to have x on one side, everything else on the other side. What happens if I do minus 8? I get 2x equals minus 6. My arrows are a bit wonky, but from here I can do my final step of dividing by 2 to get my answer of x equals minus 3. Again, continuing with the first example works as well, but it's more confusing what you have to do in the final step. So it's easier for you to start by removing the lowest amount of x's. So let's summarize this. We keep our example here. What steps are we taking? Our final goal is to have x on one side, numbers on the other. Our first step is to have only x on one side. So we look at which side has the least x's, or who knows, r's, q's, p's. In this case, that was our minus 4x because that was lower than minus 2x. That's the one that we take off on both sides. Let me write that as a taking off, so that that's actually minus 4x, which, if you remind yourself, is the same as plus 4x, which is what we did earlier. So this even holds if it's negative, like in this case. Okay, then we have an easier equation, one with only x on one side and then a number, and also a number on the other side. So then you look at what separate number is still there. In this case, that's plus 8. And we also take that off on both sides. Now we haven't seen that case, but this still goes even if this plus 8 is a minus 8, or is a minus 13, or minus any other number. And then our final step, we look at how many x's do we have. Well, we have 2 x's here. So we divide on both sides by that number. Taking these steps and taking into account that you always do it on both sides, everything you do on both sides, you should always be able to solve any linear equation that you get. So that is the reminder video on how to solve linear equations. I hope this helps and you are able to solve your linear equations now.